Good morning, children. This is 12th Physics, chapter number 4, Magnetic Effect of Current. Today we are going to start with the topic that is force on a charged particle which is moving in uniform magnetic as well as electric field. In the last class, we had derived the formula for the force on a charge which is moving in magnetic field, right? So here we are going to combine the force when the charge is moving in electric field plus the force when the same charge is moving in magnetic field, right? So we will give the total force, and that total force is named as Lorentz force, right, children? So Lorentz force, the force experienced by a charged particle which is moving, right? The particle is moving, it is not static. Where it is moving, where both electric and magnetic field are present, that force experienced is known as Lorentz force. Okay, now force due to electric field, this already we have done in unit number 1, that when a charge is moving in electric field, the force on it is given by F equals to QE, where Q is the charge that is moving and E is the external electric field strength, right? And here we have used the symbol for force as Fe, where E indicates the force due to electric field, right? So this we have already done in unit number 1. Here the direction we know vector, this is vector. So both are having the same direction, that is the direction of the force due to electric field is same as that of the direction of the external electric field. Now this is due to electric field. Now let's see what is due to the force acts due to magnetic field, which we have derived in the last class. So you can go through the recording of the previous class for this derivation. So here children, Fm equals to QB cross B, where Fm is the force due to magnetic field, means when the charged particle is moving in external magnetic field B with velocity V. Then the force acting on it is given by Fm equals to QV cross B, where Fm is the force due to magnetic field. So your M indicates magnetic field. And we had seen that F force is a vector quantity. V and B, they are vector quantities. So here the directions will be involved. So the direction of F is the perpendicular to the plane that is containing V and B. I mean it is in the direction of V cross B, right children? So this we had done. So this is the force due to magnetic field, but we want force due to both of them. So we want the total force. So the total force is the addition of the two, which will be, instead of Fm we can put QV cross B, that is the force due to magnetic field, and instead of Fe, that is force due to electric field, we can put QE. Now taking Q common, we will have in the bracket E plus V cross B. So your F equals to Q bracket E plus V cross B. This is the total force experienced by the charged particle in electric and magnetic field. This is your Lorentz force. Right, children, this is your Lorentz force. Now, in Lorentz force, one very important thing that you have to keep in your mind is that when the electric field and magnetic field, right children, when these are perpendicular to each other, when they are perpendicular to each other, when they are in perpendicular direction, the Lorentz force will become 0. This also we had seen in the last class. If you remember, we had done F equals to Q V cross B, right children? So this is VB sine theta. And if they are, right, and if they are perpendicular to each other, then the Lorentz force becomes zero. The entire Lorentz force becomes zero, but only for the particle which is moving with a particular velocity. Let's see what it is. So children, here there are few cases. Case number one, if you see, here the vectors V, E and B. V is the velocity vector, E is the electric field vector, and B is the external magnetic field, right children? Now, if they are parallel to each other or they are anti-parallel, right? If they are parallel, the angle will be theta, 0, theta will be 0. And if they are anti-parallel, the theta will be 180 degree. So in that case, the magnetic field force Fm equals to Q V cross B. Cross hai means sine theta. So sine 0 is 0 and sine 180 is 0. So when they are parallel, the Fm becomes 0. Fm becomes 0 in Lorentz force. That was the total force. So what is remaining, children? Only Fe is remaining. And we remember Fe is what? Fe is QE. Right? Now we know force equals to what? According to Newton's second law of motion, F equals to ma. That is equals to QE. And if we make a subject of formula from this equation, we will get the acceleration that is produced in the charged particle. E is equal to QE upon m. So when V, vector V, vector E and vector B are parallel or anti-parallel, magnetic force 0 हो जाएगा, but electric force will be there, and that electric force is this, and from this electric force we can get the acceleration. That इस force की वजह से जो आपका charged particle है उसकी velocity में क्या change आएगा, उसकी velocity कितनी तेज हो जाएगी, because it is in external electric and magnetic field. Magnetic force 0. So because of this electric force, the charged particle will get accelerated. Its velocity will increase by this much, right? So it will increase in the direction of electric field. Only its speed is going to increase. There is going to be no change in the direction. In whichever direction it is moving, it is going to move in the same direction. No change in direction. Only there will be change in the speed, velocity, momentum, and kinetic energy. Right, children? This is the case when V, E, and B are collinear, means they are either parallel or anti-parallel. Now, next case is, children, for when V, E, B are mutually perpendicular, means 90 degree to each other. So, this is the case when, children, this is the case when their total Lorentz force will become 0. Their total Lorentz force will become 0. Right? Lorentz force will become 0 for a particular velocity, for a particle with moving with a particular velocity. Lorentz force won't be 0 for all the particles. Only for particles with a particular velocity, उसके लिए Lorentz force 0 हो जाएगा. Let's see how. So let's proceed. So if E and B are perpendicular, then the total Lorentz force becomes 0, right? No force means there is no acceleration. कोई force नहीं लग रहा है, so it is going to move as it has entered in the same direction with the same speed is going to move, right? It means that the particle will pass through the field without any change in its velocity. Right? No change, no deflection. So the total Fe is equals to Fm, means the force due to electric field is equal to the force due to magnetic field. The forces are not going to be 0, but the total force are going to be 0. Total 0 होगा क्योंकि Fe and Fm equal होंगे, and once they are equal, they are going to cancel out each other. So if Fe is equals to Fm, we know Fe is QE. And Fm is magnetic force, that is QVB. अब आप बोलोगे मैम क्यों v क्रॉस b क्यों नहीं आया, because they are perpendicular. So and if they are perpendicular, we know sin 90 is 1. So QVB sin 90, that is QVB, right children, as they are perpendicular to each other. So QQ will get cancelled. So then QQ gets cancelled and V equals to E upon B. Now here we know E is external magnetic field and electric field and B is external magnetic field. Means वो particle जिसकी velocity होगी ratio of क्या electric field आपने apply की है upon how much magnetic field have you applied, which is in Tesla, you know, right? So उसका जो ratio करोगे, right? Suppose आप electric field apply कर रहे हो about 100 and magnetic field you are applying 50, right? So 50 upon 100 by 50 is 2. Means the particles with moving with velocity 2. Will not go with the units right now. So a particle moving with velocity 2 is going to move through the field straight away without any change in its velocity. No change in direction, no change in velocity, right? So with the help of this, children, we can make a velocity selector. Means for example, हमने बहुत सारे particle incident किए हैं in a electric and magnetic field. हमें but कुछ ही particles चाहिए with a particular velocity. तो वो velocity हम set कर सकते हैं बेटा by setting the external electric field magnitude and by setting the magnitude of the external magnetic field, electric field and magnetic. इसको set करेंगे तो whatever will be the division answer. For example, if you are giving electric field of 500 and you are putting magnetic field of 50, so 500 by 50 means it is 10, means you want, so you are adjusting according to it. So with this the velocity selector can be made, right children? So this is your next topic, that is velocity selector. So velocity selector is what? It is a device which will select. What it will select? It will select charge particles. Which charge particles will it select? It will select a charge particles which are moving with a particular velocity. वो velocity कौन decide करेगा? That velocity we will decide, because we know that velocity is E upon B, where E is the external electric field which we are giving and B is the external magnetic field which we are giving, right? Their magnitudes. So we can select the particles through a magnetic and electric field region of desired velocity. That is your beta velocity selector. Velocity selector principle, we know it's based on the Lorentz force, right? Now, this is the diagram. Before going to the diagram, I'll explain you the description, and that is here we are having magnetic field that is denoted by cross. If you see in the diagram here, this is these cross you can see, right? The cross are that the magnetic field is, children, into the paper. The magnetic field is inside the paper. Okay, this is your magnetic field. Now we should be having electric field, so magnetic field is along z-axis, electric field is along y-axis, and velocity, the particle is moving, we are throwing the particle in the x direction. So if you see the diagram here, inside the paper means along the z-axis we are having the magnetic field B, right? And we are applying electric field along y-axis, right? Whatever electric field we are applying, that is along y-axis. Here you can see this wires, we are passing current, right, along y-axis, and we are throwing the particle along z-axis. So here you can see, children, that that E, V and B, all three are perpendicular to each other, that is x-axis, y-axis and z-axis, right? So as they are perpendicular, we know that the Lorentz force will be 0 for the velocity for the particle whose velocity is E upon V. हमें ये पता है, right children? So as electric field, magnetic field and velocity are perpendicular to each other, the net force will be zero. For whom? Not for all the particles. For only those particles which are moving with velocity E by B. And only those particles are going to go straight without any deviation, without any deflection. They're going to pass straight away through the electric and magnetic field, and they are received on the other side of the screen. And rest particles, they get deviated. Let me show you the diagram once again. Here you can see, children, I think the diagram is little bit cut. So here we are putting a screen. यहाँ पे बेटा this red color line which I have drawn is a screen. And here you can see this yellow color particles, they are not having the velocity E upon B. उनकी velocity E by B नहीं है. So they are getting deviated. You can see that their direction has changed. But the particle with velocity E by B is the blue one, which is passing straight away through the electric and magnetic field. And here we can collect them at the screen, right? And of other velocities, the particles will be collected at other places on the screen. So this is your children velocity selector. Very easy topic. I hope you have understood.